Alrighty, howdy everyone. How are we feeling? Great. Okay, so welcome to your final review session. I will have one more tomorrow, probably at the earlier 7:30 to 8:30 on Zoom for any last minute things you may need, and that's for both the 12:40 and the 3 o'clock class. Like tomorrow's the last thing I'll do for your final, besides be in the room. And then tomorrow's thing will be recorded and posted along with this one. Any questions for me before we get started? How do we feel? Gigs, no gigs? Silence. Okay. What do you want to see today for this review session? Yeah, go ahead.
On exam 5,
yep,
I'm looking at form A. There are 2 questions that I have looked at and have no idea.
Exam A, exam 5, you said?
Yes. More specifically A9. But
okay. A9, and then what's the other one?
A10.
A10. Okay.
Any of them.
Okay. So how best do I want to do this? I think I'll write the question. Okay, so for A9, we're saying that we have 36.78 milliliters. You're not seeing anything. Okay. So this is question A9 off of exam 5. Y'all can read that. So it says 36.78 milliliters of 0.0105 molar HCl is required to reach the equivalence point in the titration of 25 milliliters of ammonium solution, and the KB is of ammonia is 1.8 times 10 to the -5. And we want to know, what is the original concentration of NH3 before the titration began? Okay. Does anyone know how to do this question? Where would we start?
All right. Yep.
Yeah, absolutely.
So we know that to neutralize it, we need to have this corresponding amount of acid and base, since KB measures how strong the base is. It gives us so the HCl is a strong acid, so you just completely dissociate. So that if based on stoichiometric reactions, we can then see from the KB how much we had.
Yeah, you're on the right track. So a lot of good things were said just now. So what we have to notice is that we're given a KB for ammonia. What does that mean KB is, or ammonia is in terms of like classification? It's a base, and what kind of base? It's a weak base. We know that NH3 is a weak base. And what is HCl? It's a strong acid, okay? What do we know about a titration and the equivalence point? Good. Okay, so I would start by just allowing myself to say, okay, I know that ammonia is a weak base. I know that hydrochloric acid is a strong acid. And I know that at my titration point, I need to know that my moles are equal. The next thing I would do is I would probably write out what reaction is actually happening. So we also said that as a strong acid, your HCl is going to completely dissociate. So HCl turns into H plus and Cl minus. Okay, so when we say that we have NH3, we're in water, we're going to form NH4 plus and OH minus. So what's being titrated is this OH minus and the H plus being added from your hydrochloric acid. Okay, any questions so far? Alrighty. So now that we know that, what else do we know? Or what other information can we find? Yep, so we know that any weak base will not fully dissociate because it is weak, and also because we're given a KB. So if you're given a KB, it will not fully dissociate. And if you're given a Ka, it'll not fully dissociate. So what else can we do? Go ahead. Yeah. Yep. A lot of the times for Ka, right, we have just a regular acid, and we say that just dissociates, excuse me, into H plus and A minus. But what's really happening is that you're saying you have HA and H2O, and this forms the H3O plus and A minus. So that's how it would look the same for the A, but we shorthand it because H3O plus is just H plus. Yep. Great question. What else do we know? What else can we find out? And how do we find that? Good, right? We can find moles of HCl from our molarity and the amount of volume given. What's our unit for molarity? Moles over liter. So if we have 36.78 mils, we can say that 1,000 milliliters is 1 liter. Then we have 0.0105 moles over 1 liter. And we say we have this much H plus. Questions that we found that much H plus? Now that we know H plus, what else do we know? What else can we do, or what can we do from here? Say it again. So we don't need to do that necessarily. We do know the concentration of NH4, but what is better to know? Yeah, we want moles of OH, right? Because that, right, both of those are going to tell us what our KB on the product side is, right? We know that this much H plus is required to neutralize. What's it neutralizing is that OH minus. So whatever this amount of hydrogen ions we have is the same amount of OH minus ions we have, because that's what's getting neutralized. Does everyone follow that logic? So if we're looking at our reaction, we have this many moles of H plus. Where is that technically in our ice table? Is that the initial, the change, or the equilibrium? That's our equilibrium, yep. So if that is our equilibrium, what else do we know? Yep.
How? I thought that was moles of NH3. How is that not? How is that OH minus?
That's his moles of H plus. Because we use the concentration from HCl.
Right.
And so that's going to completely dissociate. So whatever moles of HCl you have will be equal 1-to-1 between HCl and H plus.
So
Yep. Mm-hmm.
I get that. I thought it was HCl equal to NH3. Like, why is it not that?
So if it's HCl and NH3, it's like technically that, but we have to look at the background chemistry that's happening, right? It's not going to be, because those are 1-to-1 in terms of the base and the acid, then it'll end up being the same. But what's really being neutralized and what's really equal is the acid equaling the base in terms of H plus equaling the OH minus. Does that help?
We'll just keep going.
Okay.
I'll play out the
Okay.
stars on the line.
Yep. So if we know OH minus, what else do we know? Yep, we know X because this would be plus X and plus X. Okay, we assume 0. So what else do we know? We also know NH4. What else do we know? Yes, right? So we say X is our change, but really X, what that we're looking for is this question mark. We're like looking for the initial concentration. So, you know, question mark minus X is going to be our equilibrium. But we know what X is because that's going to be our concentration that we have right now. Right, so this is minuses. Any questions on this so far? Okay. So now we have KB. We have X squared over question mark minus X, which is What do we do from here? Yep. We can do the shortcut. This can become 0. We can assume that that's 0. So you can solve for question mark. What do we get for question mark?
21.44.
Yeah, that's wrong. Check your parentheses. Yeah. Anyone else get an answer for question mark?
0.008.
I got 0.0083.
0.00.
Yeah.
That's in moles, and then
This is in moles.
you can just divide by 25 divided by 1,000.
Close. Is it?
And that close. Nope, that's close.
Yeah. Yeah, I think you need to convert to. Oh, I might have screwed this up a little bit. I think you need to, sorry, I did. We were supposed to use our volume sooner than we did. Because we did an ice table, which is supposed to be in concentration, and we just did this in moles. Sorry.
Our ice table's always in concentration?
Yeah, anytime you use ice table, you always want to be in molarity. Okay, so let me just think about this for a second where I want to do this.
Test question, by the way.
I haven't looked at acids and bases in a month and a half, so just give me a second.
Basis and readout, yeah, the two things I just did, well, not all acids and bases, but the ice levels.
Yeah.
But the two things I just didn't get. Just one.
No shot.
Okay, I mean, you could also do that. So I guess you can also do that. Because you just did
No shot.
ACL and NH3. So then if you did I'm gonna have to think about that chemistry for a second. I don't think I necessarily agree with that, but okay.
You were expected to know this in 2 weeks.
Yep.
Friendly reminder.
I mean, it's not my test. Okay, so yeah, because you have the whole equivalence point.
Isn't equivalence point?
Yeah, when moles are equal, I guess that makes sense in my head. Yeah, so sorry, it's been a long day. Okay, so if we think about a titration curve, in terms of this one here, right, we're gonna have this, and then we're gonna drop down and we're gonna be here. So at this point here, this is where your equivalence point is. And this is where moles are equal. So in this slope range, it does not matter the type of acid or base. You can just use M1V1 is equal to M2V2, but we have to remember if you have a diprotic or a monoprotic acid, you need to take that into consideration. So in this case, since we have HCl and NH3, These are both monoprotic acids, right? You only have one H plus here. So you can just use M1V1 because this will give you your moles. Right, as we did in the beginning. And that'll equal the amount that you need as your X for the molarity of your base. If the moles are equal, you can always use M1V1 equal to M2V2. Yep. Sorry to confuse you with ice tables right off the bat. Does that make sense why we can do M1V1 equals M2V2? We don't need to worry about this dissociation stuff up here because we're at that equivalence point section of your titration. If we were in this section here in purple, what would we have to use? This would be the Henderson-Hasselbalch equation. Oop. What is the Henderson-Hasselbalch equation? A minus over HA. Yep. And then in this region here, what do we use? Yep, this is just the excess of what is it that called that you're being added to? Titrant. Whether that be the acid or the base, you're just looking at how much extra you have, and then you use ice table. Yes, yep, you couldn't use the Henderson-Hasselbalch in that blue box that I have because there is no half dissociation, right? At the blue box area, you now fully have your strong acid or your strong base, so it'll fully dissociate. And so any excess that you have will just become the concentration of that OH minus or of that H plus ion. And then we'll do A10. We'll come back to that as well. A10, okay. Yeah, I'm gonna write it. We're gonna do A10 from exam 5.
So M1, V1 can be used at the equivalence point for anything strong, strong weak acid,
Yep.
all the things.
Yep.
Is that the intended solution?
Yes, I believe so. I think you can use an ice table for that as well.
Oh, 'cause he gave us
Because he gave you KB, and I think you definitely can do that, but the shortcut is that. And it's intended to be 13 points, which makes me think that people probably wanted you to use an ice table, but you can just use M1V1 is equal to. This is A10.
Okay.
Yeah, question A10. Okay, so for this one, we have 25 mils of 0.356 molar solution, ammonium, was mixed with 40 mils of 0.842 molar potassium nitrate. What is the final pH? Okay, who's got ideas how to do this? Okay. What else can we do? Yep. But there's something we could do first that's going to make our lives a lot easier. Yep, we're going to write the equation of what's actually happening. So we have NH4 plus, and what is potassium nitrate? K Close, NO3. Yep. So someone tell me, what is potassium nitrate? It's a neutral salt that adds nothing to this equation. What is the only thing that potassium nitrate is contributing to our question? Volume, right? We only care about the 40 mils of volume that the potassium nitrate is contributing. Yes.
How are we supposed to know it's a neutral salt?
So we do know that your group 1 atoms, or your group 1 elements, and then your and then some of the polyatomic ions will be spectator ions. He told you like a chart of some things that are spectator ions. But if you break this apart into its two components of K plus and NO3 minus, if we ask ourselves what acid or base did this come from, what base did K plus come from? KOH. What did NO3 minus come from? HNO3. What are both of those? They're strong. Yep, this is gonna strong. KOH is a strong base. What about HNO3? Is a strong acid. Yep. So since both of those are strong components, they cancel out and they don't contribute anything to your solution. Does that make sense why potassium nitrate is doing nothing here? Yes. Yep. Because then, so if this was instead, right, if this was not KNO3, but instead this was KNO2, right? It was potassium nitrite. This now comes from HNO2, which is a weak acid, right? And now you have a equilibrium that you're now fighting with, which is like the challenge question from either the homework or the practice exam for exam 5. So I don't think he's going to ask that type of challenge question on the final exam. I think he would ask something like this instead. But yes, so since that one would be a weak component, then that would contribute. But since we have 2 strong components, this only contributes its volume. Questions on that? Okay, so now that we know that this is just contributing volume, we can do our rice table or ice table, whatever you like to use. And if we're writing our reaction, we have NH4 plus, and what is that going to do? First of all, is this an acid or a base? This is an acid, right? So is that going to gain a H plus ion or remove an H plus ion? It'll remove, right? If we had water in solution, this will donate its H plus, and it'll create NH3 and H3O plus or H plus. Questions on the reaction happening? Okay. All right, just gonna. Okay, how do we set up our ice table? What do we need to plug in for the initial of NH4 plus? Well, we need to find our new volume, right? So we have a new concentration, so we need we have a new volume, so we have a new concentration. So we start off by doing M1V1 equal to M2V2 to find our new concentration, where we have 25 mils and 0.356 equal to X, our new concentration. And what's our final volume? 65. Do you need to convert to milliliter or to liters from milliliters here? Nope. They will cancel out in the very end. So X gets, I think it's like 0.16. So now this new concentration, we plug into our initial concentration in our ice table. How do we fill in the rest of our ice table? Yep. Um, So for exam 5, this is what you were given at the top of the exam. What are we using here? Yep, so we need the Ka for the NH4 plus, which is equal to the 5.55 times 10 to the negative 10. Any questions why we're using that one? If we were given the Kb for NH3, would you still be able to solve for Ka? Yes, yep, right, you could just use the Kw to switch between the two. Okay, so we have 5.55 times 10 to the negative 10 equal to x squared over 0.137 minus x. Can we use the shortcut here? Yep. So I get squared equals. And how do we find pH? And what does pH become? 5. That makes sense how we do a 10. Yes. Everyone understands the whole spectator ion thing and where that comes from. Yes. Right, if it was sodium, someone give me another one that it could be. Be sodium carbonate or chlorate, right? We could have done this. This would have been a spectator ion. Could have been sodium chloride. That would have been fine. Anything like that, all of those would have been spectator ions as well. They would not have contributed anything besides its volume. Yes. Yep. Because it's chemistry. Any other questions on A10? Okay. Yours B9? This is exam 5, but B9. Yep. Okay, so B9 from exam 5 is in a titration 354 milliliters of 0.21 molar formic acid was added to 126 milliliters of 0.9 molar sodium hydroxide. What will be the pH at that point in the titration? What do we need to check for first? Say it again. We can check if there's a spectator. Yep. Is there anything of concern? Yeah. So essentially we want to check how many moles of acid and base we have first, right? We're given a volume and a concentration for both acid and base. So we want to see where are we in our titration. So for our acid, right, we have 0.21 molar times 0.354. We end up with 0.07434 moles. And we're going to do the same thing for our NaOH. Here we do need to convert our milliliters to liters, just be mindful of that. What do we have in excess here? Or I guess, are they equal? So are we at the equivalence point? No. Which one's in excess? Our base is. So does that mean that we're before or after the equivalence point? We are after the equivalence point. Spell it. Okay. How do we find how much is in excess then? Yep. All of our acid is going to be neutralized, so we'll use up all of our limiting reagent or the moles of acid. Yep.
Here's about the wording of the question.
Yep.
Because it says we're adding the acid to the base, so if the base is a titrant, then if you have more base, then why is it after the
So it's a poorly worded question because your strong base should be the thing that's getting added.
added to?
Yeah, it says it's added to the strong base, but you should be adding the strong component or else you won't ever see like the nice curve that we're looking for. But at the end of the day, if you solve for your moles of acid and moles of base, you see that you have excess strong base. And so you just know that you have to, if you have excess of something strong, then you can just use your ice table directly. Does that help at all? Not really.
It's confused because in lab when we start with the base, we just ended up flipping the curve.
Yeah, you just end up flipping the curve. And in this case, it should be written that your base is added to your acid, because if you do your titration this way, you won't ever see the nice like half equivalence point and then the equivalence point. But it's just a poorly worded question here. Yep. Yes. Yep. Because if you have your pH probe in the strong thing, it'll just stay very basic at this point until you hit the equivalence point. You want to see the nice curve. Okay, so we have this much excess of NaOH. So how do we find pH?
Find the amount of H plus or HBO.
What did you say? Yep, so we can find the concentration of OH plus, or OH minus, excuse me, or H plus if you have a strong acid and if you are asked a different question. But in this case, right, NaOH will completely dissociate into Na plus and OH minus. So all of your moles of your NaOH will become your moles of your OH. Minus. How can we find concentration of OH minus? Yep, so we want to divide by total volume of solution, which is 354 mils plus 126. So this is that concentration of OH minus. So how do we find pH? Yep, so in order to find pH, we have to find the pOH first. How do you find pOH? Yep, we'll take the negative log of what we just found. And then how do we find pH? Yep, and then we'll subtract this from 15. Or 14, excuse me. Because you just have excess strong. So everything will just completely dissociate and you don't need to use your ice table. Yep. Yep. Yeah.
You just said that it's beyond the equivalent to use ice tables.
If I did, I apologize. You technically could still do one, but you don't have to. Your ice table comes in with your Henderson-Hasselbalch. I might have just misspoke. It'll come in with your Henderson-Hasselbalch to see how much of each you have. But for your past the equivalence point or after the equivalence point, when you just have excess strong component, it'll just completely dissociate and you can just use pH directly from your excess concentration. What questions do we have on B9? Does this make sense how to do B9? Yes, okay. Next question. Exam 1, Form D. Question 11. Yes.
I'm trying to use that the natural law with like the P1 over P2, that formula.
Okay. Yep. Okay. So for on exam 1, question D11, we have an unknown liquid boils at 105 degrees Celsius. At 0 degrees Celsius, its vapor pressure is 6.91 millimeters of mercury. What is the molar heat of vaporization? And what equation were you trying to use?
This is ln of P1 over P2 equals H over R, and then it's multiplied by the 1 over P2 minus 1. So like I got stuck because I don't have another.
Okay. Give me 1 second. I just need to check to see if I'm thinking correctly. Okay. So the thing you needed to know here was that at normal boiling, vapor pressure is equal to 760 millimeters of mercury for 1 ATM. Yeah, so that would have been that second pressure. So for everything, yep. No, that piece of information is not given at the top, but that is, if you might, I don't remember if this was in the notes at all, but there's one chart that looks like this, right? It's like this kind of graph here, and they go like this. And they say this is 760 millimeters of mercury, and depending on the thing, you'll have different, and this is temperature. So at different temperatures, this is your boiling point where it crosses that 760 millimeters of mercury. So this might be H2, CO2, and H2O. So they will have different temperatures of boiling, but they all boil at that 760 millimeters of mercury. Yes. So if we were to plug in this equation, what would we have? We would have ln, what would be P1? Yeah, it could be the 760. What would be P2 then? Yep, 6.91. We don't know the delta H of vaporization. What is R in this case? Yes. What is T2? So that'll actually be T1, right? Since we plugged in pressure 1 of 760 where it's boiling, we want to use the 105 as our T1, which would be second. So this one would be 273. And then this would be 378. Right, so our higher pressure and higher temperature go together, and then our lower pressure and lower temperature go together. In this case, we are 8.3 would be volume, and then because you are using a temperature and a pressure, I think you need the temperature and pressure R. Yeah. Yep. Yeah, because this one has units of ATM times liters over mole times Kelvin. And then the 8.316, or sorry, 8.314 is joules over mole times Kelvin. And so since we have those pressure components, we want to use the one that has the pressure unit as well.
Sorry, how do I know, because I have my lecture notes, he told us to end in joules in Kelvin, so where do we?
Let me just do this real quick and then I'll just make sure that that's correct. Wait, oh, okay, I'm sorry. I missed this part of the question. So it's asking for in kilojoules per mole. So this does want to be the 8.314. Sorry, because not this arrow now. This one ends in joules. Gives you those units here. And the pressure units will cancel out in your LN. Yes, yes. No.
If it was the 806.
Yep.
Then we could change the 750 and 21, is there any?
You do not. Nope. And for the LN portion here, those will cancel out when you do the math anyways. So you wouldn't need to convert them at all. And in this case, you don't need to convert them to like something else either because you're ending in joules. Does that make sense while we're using the 8.314? Yes. Well, you're looking for this delta H of vaporization, so which is going to be an energy component. Any questions on D11?
So I did it at -30 times. Which is an answer that is wrong. But also, it is also historically wrong. So. Okay.
Got this side to be. Yeah. Yeah. This is like 4 point something, I think. And then you have delta H. So you get 384.3. And this is in joules per mole. So then you want to convert it to kilojoules. So this would be 38.4 kilojoules. Yes. Yep. Everything boils at 760. Yes. Yep. So in this case, right, you don't need. Yeah. Everything boils at 1 atmosphere. Yep. Yes. Yep. We can move on to the next one.
Do them for a or a
Exam for.
I just don't understand.
Yes. So that's the tricky one.
They was on like every or almost
Yeah.
every form.
Yep. I think on the questions I gave, I do this one, but I asked for POH as well. So you can try it again that way too. So this was exam 4, question A14. Okay, so for this one, it writes out 98, but whatever. 98 grams of sodium acetate were placed in 764 milliliters of water, such that the final volume was 784 milliliters. What is the pH of the solution? So the big thing to note with this question here is that at the top of your exam, you're given this one. This is the only time you see acetic or acetate anywhere. If we were to look at the Ka for acetic acid, I usually write this as HAC for acetic acid, which would dissociate into the acetate ion and the H+ ion. What are we given in our question? We're given sodium acetate. So we're given NaAC. What is NaAC going to do in solution? This will completely dissociate into Na plus and AC minus. So what does Na plus do? Na plus is a spectator ion. So when you have this fully dissociated solution that you then add to water, your Na plus doesn't matter anymore. And now you're left with an equilibrium. So you're going to use acetic acid to do what? You need the Kb for acetic acid. Yep. So if we are going to solve this out, right, the equation that, or the chemical reaction that's happening is that we have AC minus plus water is now going to form acetic acid and OH minus. We now have an ice table situation, but what do we not have right now? That we need. Yeah, we don't have a starting concentration. Can we find a starting concentration? How do we do that? Yep, we can do the 98 grams and we can say that 1 mole will be equal over 82 grams. This is 1 point. How do we get to concentration from here? You would divide by your final volume. So by that 784, and we get 1.52 molar. Where does that 1.52 go? Yep, that goes into our AC minus initial concentration. How much acetic acid do we have? It's not a trick question. We have 0 of this. Right, now it just becomes the usual ice table. But we have to do one more thing before we start, right? We're given Ka is equal to 1.8 times 10 to the negative 5. But what are we using? Kb. How do we find Kb? Through Kw. Yep. Kw is equal to Ka times Kb. What's Kw? Yep. Yep. So we're given acetic acid, which means that it is the acid form of the acetate ion. We are starting with the acetate ion. We're starting with its conjugate base of acetic acid. Yep. And you forming the OH minus, which means that you're in a base dissociation. Does that make sense why we're using Kb? Yes, everyone else? So then Kb is x squared. Can we use the shortcut? Yeah, this one's good to go. Oh. And we get x equal to how do we find pH? The negative log, and what is that going to give us? This is POH. Yep. How do we find pH? Subtract from 14. Yes, like how we get to what's happening. Yep. So you kind of have to think about it in like two solutions, right? You have this 98 grams of sodium acetate. So you have the salt version of sodium acetate, and you're going to put it in water and mix it up. What we're saying is that when it immediately hits the water, it's going to split, right? Because we have a sodium ion, and anything in group 1 will always be soluble, so that will completely split. Once that completely splits and dissolves, we now have sodium ions and we have acetate ions in solution. Those acetate ions will now start forming an equilibrium with the water molecules it's now dissolved in, where it will then start taking some of the H plus ions to form the acetic acid and the OH minus. But because that sodium is not going to do anything with the water, it just hangs out. So you can assume that it's like right as the reaction happens, we form the initial concentration that we have with no acetic acid and no hydrogen or hydroxide ions. Yes. Yep. So all of that acetic acid from the sodium acetate is available to react with the water, forming the equilibrium. Yes. Yep. Yep. So the acetate is basic because it's the negative ion, the conjugate base of the acetic acid. Yep. Great questions. What other questions do we have? B11 of exam 5? Yep. Okay, so for this question here, we say how many grams of silver chromate will precipitate at equilibrium if 7.47 millimoles of silver nitrate are added to 12.6 millimoles of sodium chromate in 15-liter final volume. Okay, walk me through. What are we doing? Yep, so we want to write the equation. So we know we're looking for silver chromate. So I'm first going to write my KSP of what that's going to look like. So I have Ag2 CrO4. What is that going to form in terms of KSP? Mm-hmm. 2 Ag plus and then CrO4. How many? Just one, and what's the charge? Yep, 2 minus. Okay, but what else are we given? What are we adding? We have silver nitrate. What is that going to do? That'll fully dissociate. So this will be Ag plus and NO3 minus. What does sodium chromate do? Fully dissociate. So all of the millimoles that are being added, what does that turn into? It'll just turn into the moles of the 2 ions that we're looking for. Your nitrate and sodium become spectator ions, and we don't care about them. But the 7.47 millimoles of silver nitrate becomes that many millimoles of silver. And the 12.6 millimoles of sodium chromate becomes that many moles of the chromate ion. Everyone follow what's happening so far? Okay. What is KSP in? Is that in moles or is that in concentration? That's in concentration. So how do we find the concentration of these 2 ions? Yep, we could divide by the 15 liters, right? So if we wanted to find concentration, be 7.7. Okay, so that's just concentration of the ions we have in solution. So that help us solve for how much is going to precipitate. Not really. What do we need to solve for first? Say it again. Not yet. Yeah, so we should be able to solve for Q to see if it precipitates at all, right? So for Q, right, we don't know where we're at. So we need to take our concentration and say 4.98 times 10 to negative 4 squared for the silver and 8.4 times 10 to negative 4 for our chromate. Bless you. What is Q compared to K? Yep. Q is greater than K. So which way does our reaction proceed? Towards the precipitate, right? We're going back this way towards precipitate. So a precipitate does form.
I'm a little confused because I know you don't use like use the solids, you wouldn't use the precipitate, but are we? Oh,
Yeah, are you okay?
I was just confused because we do products over reactants, and so I thought it might be like the denominator, and we had to do something weird. But
No, no.
we do it based off of that.
Yes. Yep. We're doing based off of the KSP. So this portion up here.
Okay,
Yep.
I did.
Alrighty. So if we know that a precipitate's form, yeah. Yep. So we saw, so our concentration of silver, or of silver ions in solution is from that 4.98 times 10 to the negative 4. So we know that from the reaction that's boxed above, if we were to just write KSP for this, it would be Ag plus squared and your chromate ion. Okay. So we're taking the two concentrations that we just solved for and plugging them into K, but we're solving for Q because we don't know if we're at equilibrium or not. So once we found that Q equals 10 to the negative 10, that is larger than 10 to the negative 12. So since Q is bigger than K, we have to proceed towards our reactants. Does that help? Yeah. Okay, so if we know a precipitate is forming, what do we have to do now? Say it again. Yes. So what do we do instead? I heard someone say it. So we have to solve for KSP, or we have to use our KSP to find X. So if we're, again, we're still given that silver chromate is going to dissociate into Ag plus and chromate minus. So we're going to solve for, or we're going to use KSP to solve for X for what that solubility product value is. So we'll say that 9.0 times 10 to the negative 12 equal to, what do we plug in for Ag plus in terms of X? I agree with X squared, but there's something else we need. We need a 2 as well. So 9.0 times 10 to the negative 12 is equal to 4x cubed. So X, once you solve this out, would be equal to 1.3 times 10 to the negative 4 molar. Because we need to know how much we're allowed to have at equilibrium. Right. Yep, this is the maximum amount we can have, and then everything else above that will make it shift towards products, or shift towards precipitate. Yep. Okay, so if this is X, right, what concentration is going, right? This is how much we can have at equilibrium. So how do we solve for how much is getting, right, used?
I don't know.
Yep, so we have to do a little bit of subtraction. I'm just looking at my notes. Okay, so right, we said, I'm just gonna write, we have 4.98 times 10 times 10 to the negative 4 silver plus, and we have 8.4 times 10 to the negative 4. Right, this is how much we have in solution. How much can we have? How much are we allowed to have in solution?
1.31.
So that's
Dang.
just X, right? If we were to write out, you're very close.
Can we double it for 7?
Mm-hmm. Yep. So, right, if we were to write this out, if we were to write a little ice table, at equilibrium, we're going to have X and X. So you're allowed to have 2 times 1.3 times 10 to the negative 4 molar, which is 2.6 times 10 to the negative 4. And you're allowed to have 1.3 times 10 to the negative 4 molar of your chromate. Right, so if we're allowed to have that much, everything else needs to get used up to make our silver chromate. So how do we solve for how much is getting used? Yep, we have to convert to moles. So we have to use that 15 liters. Yeah, I did.
Yeah, he said it was a challenge.
Oops,
He did.
made an impossible question.
I did question, I think it was D10 from this exam with the silver chromate, which is a lot more manageable than this one here. So I'm just trying to go back and forth between the two.
Have you seen the final by chance? Are there any of this on the final? Like, maybe-
I haven't seen it. He will send it to me tomorrow to read through. Hopefully tomorrow.
You advise against these kinds of problems.
Yeah. Yeah. So for this one is going to require a lot more thought for me that I right now. But if you want one that would have potential to see on the exam, it's question 10 that I gave you and the ones that I prepared for you, but I believe that's from question D10 from exam. What was this? 5? Yeah, I think it's D10 from exam 5. Let me just confirm that I'm saying the right thing. Sorry, D11 from exam 5. That one is a lot more manageable, and I'm gonna post the answers right after this once I get the Zoom up as well. Yeah, it's the whole point is that you have a lot of stuff in solution, so stuff's gonna fall out and you're gonna make precipitate. The way that this one is worded and done, my brain is just short circuiting. So I wouldn't worry about this one. Stuff will have to come out. I'm just thinking about how much excess to have, because you have excess over the other, which is going to throw off your equilibrium and a whole slew of other things. But yeah, let me see. Sorry, I don't have a better answer as well. That was exam 5, B12.
Oh, yeah, it's the next one down.
Yeah. Sorry, I went to exam D, so I just want I think that one is one that you could see. Yes.
It's so short. but,
Yeah. Okay, so this one is D11 from exam 5 could show up. B11 from exam 5, I don't think will. That one's hard. This one is exam 5, B12. B12. Yep. Okay, and then let me just grab the KSP. That's PBBR2. Okay. So for this one, we're saying that we have a solution of NABR at 0.35 molar. So NABR is going to completely dissociate into Na plus and Br minus. So all of this 0.35 molar NABR will turn into 0.35 molar sodium plus and 0.35 molar Br minus. Your KSP for PBBR will form an equilibrium of lead 2 plus and 2 Br minus. So KSP will be equal to lead 2 plus and Br squared. No, right, because it's just your concentration. Yep. Bless you. So when your sodium bromate or sodium bromide dissociates, you now have KSP where your lead has no concentration, but your Br minus has 0.35 molar concentration. Yep. And then you would square it. So if you were to write this as a ice table, right, this doesn't matter. So we have IC. Your initial is 0.35, right? You have no lead, so you still have to form some lead. So you'll have plus X plus 2X, and then you'll have X and 0.35 plus 2X. And then you can solve for X. In this case, right, you, KSP, oh, -4, okay. Right, in this case, this you can say goes to 0 because it's going to be so small. Huh? Yeah, you can do the shortcut. And if you didn't, then you would end up with a cube. So if you ever end up with a cube, you can probably use the shortcut. So then, because I don't think you know how to solve a cubed root unless you are a secret math major. I am not, so I don't know how to solve that. Let me get that there. Yes. Usually it's, I think it's 2 orders of magnitude greater than your initial or less than your initial. My rule of thumb is, especially when it comes to acids bases, is that if you have a Ka or Kb exponent and it's 10 to the -5, 10 to the -6, 10 to the -7, something, I guess, less than 10 to the -5, as in, right, your number is getting smaller, then you can use the shortcut every time. Four, yep. Times 100. Yes, yep. Right. Yep. And in this case, this is like just a little less than 3 orders of magnitude, so it's good enough. And then if you were to keep it, right, then you have to do the FOIL method and then multiply by X, so you end up with the next cubed. And I don't know how to solve that. Or I don't at least remember how to solve it. So B 12 from exam 5 would be like a solubility or KSP fair game type of question. And then exam 5 D11 is another fair type of question. Yep.
How do I decide the list?
Yeah, I think that's a good one, right? If it's boxed in his slides, I would probably know it. If it's like a one-off equation where like,
I just don't know what to do.
yeah, I'm thinking, like, I don't want to say like your Henderson-Hasselbalch is a major equation, right? Your Clausius-Clapeyron is a major equation. Your yeah, Raoult's law. I'm like ish is like a medium equation, I feel like, right? All of the boiling point elevation, boiling point depression, I feel like are medium, where it's like you just need to know the Van Hoff factor, and right, like if you see that he gives you the boiling point elevation constant, then it's like, oh, I should probably use that equation, and then you should like just trigger that one that way. But I think that's a good rule. If you go through his slides and you see anything that's boxed, then that's a pretty good equation to know. I think in some of my previous review sessions, we sat down and went through a couple of equations that we know for the exam. I can try and find those or something. But there's also videos on YouTube too. So if you just kind of click through a couple of the early ones, usually we do that towards the end of the review session. Sometimes I gave us like just a regular equation to use, and then you can kind of see from those if like the ones that keep on popping up and stuff. Yeah. Say it again.
Yeah.
Oh, okay. So probably half-life is a major equation, I would, for first order, right? If you know your integrated rate law for first order and your half-life for first order, I would say that those are the major ones because that's the one we use most often. Yeah, and then you should be able to find what order something is. Yep. I would say 0 and second are minor compared to first order. I would say major if you're going to pick one to know, I would know first order. But I also haven't seen the exam, so if you need to know second order, I'm sorry. But if you also, right, if you remember your orders, you want concentration, you want ln of concentration, and then you want 1 over concentration. And so your integrated rate laws have some sort of that component in all of them. So again, I think major minor, right? If he's asking you for like who did this, I think that's minor, right? He needed just a question for the exam. Yeah, I think I think for true false for your final, he's gonna want to test your knowledge. So he wants you to say, okay, this thing is negative delta, or it has a delta H that's negative and a delta S that's negative. When is this going to be spontaneous, right? Or give you stuff like that. More of true false in terms of concepts, not in true false as this is who did this or something like that. True false of where he's going to make you like solve an equation and say this would be the answer, right? So then you can say, okay, you got the right answer, you didn't, kind of question too. I would say look at the old true false questions, look at the old which statements are correct, and the big ones that pop out as concept questions, those are the ones to focus on. Come up with your own too. That's always a good one. Make them true, make them false. Anything else? We have this room booked till 7, so you got 20 more minutes. Yep.
Question about grade coverage.
Yeah.
So. Do you have, like, are you doing it or is Linda?
I do it.
Are you dropping the lows for everyone and then doing the curve?
Yes. Yep. I
You don't make the curve then drop that.
no. Nope. I will take all of your exams, and your exams should probably go in tomorrow afternoon. For exam 7, you'll be able to see them. But I will put that exam 7 in. I will then in Excel, just drop your lowest one, right? Drop the minimum, and then I will add the remaining 6 exams. And then that'll be that'll be points out of 600.
And is there any way to know where we are with that? What percentage of people are the cutoff for A, B, C?
That depends on like how many people get what stuff. Like I don't have a set of,
So it's not top like.
it'll be, yeah, like right now, right, it's been like 16, 17, 18% get an A, like it'll probably be like 19, 20% get an A. Because people have Q drops since the beginning of the course.
So how does Q dropping affect the curve? Do you not include those people?
Uh,
In theory, the people that drop, they bring down the average, so it's like harder to get an A.
yeah, so we don't take into account, the people who take the exam is how I distribute the curve, right? I say, okay, I have 400 exams. So 20% of those 400 exam, or I guess 24% of those 400 exams are going to get a B, right? That's how that's going to go. Yeah, right. So we, instead of having 6% fail, we now only have 3% fail.
Okay, so it's in that percentage.
Yes, it's in the percentage of how we distribute it. We bump it so that, right, more people get the top end grades because you're still here, right? If you've been getting C's all semester and now the Q drops are still taken into account, but you're at the low end of the C, then now you might get a D and now you're like, well, now I suck. But if you've been getting C's constantly, then you should stay at getting a C constantly. I don't. Nope. It depends on how people do really and how much we can stretch it.
So you take into account that stretch plus the Q drop?
Yes. Yep.
What do you think? I know you don't know, but what do you think the cutoff for A is?
I would have, based off of your exam so far, I'm gonna say if you're around a 77 to a 74, you are borderlining that low A, high B. Yeah.
The average lab grade is?
I do not. I have zero idea what your lab grades are. That's gonna come in an email probably 20 minutes before I'm supposed to post your grades to Canvas.
No, not knowing.
So exam for the 3 p.m. class is on Monday at 12:30. Usually takes me 30 minutes to scan all the exams in and then 20 minutes to grade them. So after I have all of that, I just need your lab grades. So it really depends on when I get lab grades. Because I think I don't think those are due at the time of the second final. But once I have those lab grades, it'll take me 4 hours to do the distribution. So hopefully by the, yeah. Yeah, I have 3 different, three different Excel sheets, and the best way to line up the people that have Q dropped, the people that have lab but aren't in the class. I don't even know how that even works. And then just what I have from Canvas is to line up all of your student IDs, but those lists are not all the same. So some of them have more students than others. So I have to line all of those and then check to make sure they're all aligned so that I give you the correct grade. So I have to manually go through and check all of them. Well, I don't manually go through it. I have Excel tell me if it's true or false, and then I have to go in and find all the false ones. Yes, Kendall. Yes. But once I have all the grades, that's all I will be doing. Like, I will make sure your grades are in so that you know.
You've been the grading assistant for him in previous semester?
No, this is my first time working with him.
You don't know historically what the
Mm-mm.
cutoffs are?
Nope. This is actually my first time dealing with grades, period. So.
Oh.
Thank you.
Yep.
Has the university ever tried to push up this average? It's like, it's like a whole grade point lower than every other M120. And I asked because I had an honors student try and help me, like an honors like university tutor trying to help me with some problems you couldn't even go.
Yeah.
He's-
Yeah. Basically, Lindahl told me when I first was assigned to him that the university or the chem department, who's in charge or whatever, doesn't like the way he teaches, so he gives him the 120s off so that he doesn't have to. He can do his own thing and kind of just contain his students to that. I don't know.
That's why she's 120.
Yeah, that's why he teaches 120, right? Not when everyone else is teaching 120, because
Oh,
he can stick to how he wants to run the class, right? He doesn't have to, yeah, pretty much. They make him, just make him happy. He provides a lot of money for the university, so go ahead. I do, give me 1 second. Okay, so this was homework set 13. So this is saying something decomposes. Homework set homework 2, question 13. Then it stopped my projection. I don't know why. Okay. So this protein that you're doing decomposes through a first order process with K equal to 0.02 1/minutes. And we want to know how long it will take for 99% of a 1.6 mil sample of protein with initial concentration of 87 micromolar to decompose. So does anyone know the first order integrated rate law? Yeah. Yep. It's equal to, yep. Yep, so you can write it like this, or you can write it as ln of AT is equal to the negative KT plus the ln of A0. Either one of those is mathematically equivalent. So what we're saying here is we want 99% of your sample to decompose. You're in concentration, so you don't need to deal with this 1.6 milliliter sample, I wrote that twice, but you get the idea. You can just say, okay, I want 99% to decompose, which means how much percent will you have left over? You'll have 1% left over. Yep. You did the math yourself. You're good. Right. So you'll have 87 micromolar times 0.01, right? Because you have 1% left over. So that should be 0.87. Is that right? 0.1, yeah. 0.87 micromolar left over. You shouldn't have to. Yeah, because it'll cancel out. So your ln of 0.87 is equal to negative 0.02 times x, because you're looking for that t component, plus the ln of 87. Yeah. Yep. This is just if you want to use the actual numbers. So your ln of 0.87 divided by 87 is negative 4.605, which is equal to negative 0.02 times x. And so you get x equal to 230.3 minutes. You're given 0.05 seconds, 0.5 minutes, 230 seconds, 86 minutes, or 3 hours. So since none of the first 4 match anything, I'm going to convert to hours and say 60 minutes is equal to 1 hour. And here you get 3.8 hours. And how I got to this negative 4.6, negative 4.6, you will subtract ln of 87 from both sides. So it's ln of 0.87 minus the ln of 87. That's what that turns into.
Does the 1.6 milliliters matter at all?
Nope. Yeah, you can convert it to moles, but it's the concentration. So you're given a concentration, you could just keep it in concentration. Any other questions? Okay, if there's not, I can let y'all go. I'll post this afterwards, and then I'll post the answer key to the questions that I made for y'all as well. And then tomorrow, 7:30 for a Zoom if you have any last minute questions. And that'll just be a 1 hour thing, and I'll post that link with everything else tonight too. And if not, good luck. Thanks for a great year. I'll see you Friday or Monday. Then if you have exam 7, you can come find me and I'll get that to you in a second.
Just let me pick this up. If it
Yes.
ends up giving you the finals or